Hello students, in the series of video lectures, today we are going to discuss SSTF disk scheduling algorithm. Basically, SSTF means shortest seek time first. And like SJF, what happens here, select the disk IO request that requires the least movement of the disk arm from its current position regardless of direction. Means suppose this is our line and our current head is here. Now the service, suppose one service is at location X and another service is at location Y. Now अब हेड को जिस किसी भी डायरेक्शन में आइदर एक्स और वाई जिस भी सर्विस को सर्विस प्रोवाइड करने में मिनिमम हेड मूवमेंट मेजर करना पड़ेगा, मिनिमम हेड मूवमेंट आएगा, उस पॉइंट की सर्विस को पहले सर्विस प्रोवाइड की जाएगी. ओके, मींस वी कैन से इन टेक्निकल वर्ड्स which point have the minimum seek time from the current head position, that request will be served first. So I'm again repeating the definition. Select the disk IO request that requires the least movement of the disk arm from its current position regardless of direction. SSTF algorithm reduces total seek time compared to the FCFS, and generally it covers almost near about 1/3, but there are some kind of drawbacks also there, like suppose this is our line and current head position is this one. Now suppose when suppose this is the current head position, this is one request, and suppose this is one request as X, and these are our new requests, and whose seek time is less than X as compared to their head position, current head position. Now just assume अगर हमारे पास जो नई रिक्वेस्ट आ रही हैं वो सारी की सारी ऐसी रिक्वेस्ट आ रही हैं जिनका सीक टाइम इस X वाले से कम है. I'm again repeating, जो हमारे पास नई रिक्वेस्ट आ रही हैं उन रिक्वेस्ट का जो सीक टाइम है, जो हेड का मूवमेंट है, इस लेके हेड मूवमेंट से सब में कम की रिक्वेस्ट आ रही है. तो अकॉर्डिंग टू एल्गोरिथम जितनी भी नई रिक्वेस्ट आती रहेंगी इमीडिएटली सर्व होती रहेंगी भाई, बिकॉज जिसका हेड मूवमेंट, जिसमें हेड मूवमेंट मिनिमम आएगा अकॉर्डिंग टू एल्गोरिथम उसी को सर्व करना पड़ेगा. तो वो लगातार सर्व होती रहेंगी और इस पॉइंट वाली जो एक्स वाली लोकेशन पे रिक्वेस्ट है उसको वेट करना पड़ेगा. और ये वेट कब तक करना पड़ेगा? ये वेट might be possible that wait may be indefinite, because सर्विसेज जब तक इस हेड मूवमेंट से कम की इस साइड आती रहेंगी तब तक वही रिक्वेस्ट फुलफिल होती रहेंगी, इस वाले का नंबर नहीं आएगा. तो जब भी ऐसा केस आता है, what we will say, we can say there is a possibility of starvation. So basically this is the disadvantage. Starvation is possible. Stay in one area of the disk if very busy, right? Switching direction slows things down. As you can already see, not again, this is not the most optimal algorithm. Means in future lectures when we will discuss some other disk scheduling algorithms, we will measure the head moment minimum as compared to the SSTF algorithms. So let's discuss one example. I'm taking the same example that I have considered in the case of FCFS. Suppose uh, we have the same question, current head position is 100. Now, as far as SSTF is concerned, now we have to calculate the total head moment. Now, what we will see, we will find out the service or the request that have the minimum seek time from the current head position. Now, you can see from our head is at point 100. From 100, the minimum seek time will be at the location 89. So the request 89 will be served first of all. Now again we repeat the process from 89. Now this is our current head position. Now we have to find out from 89 which point have the minimum seek time. Like in one direction I have 132, in other direction I have 42. So from 89, 42 is minimum or 132 is minimum. Whichever will be minimum, head will be traversed to serve at that location. So as we can see clearly, head will be traversed from 89 to 132. Now after 132, again the same process. At this point, we will calculate the minimum head movement or minimum seek time for the remaining request. So from 132 to 187 and from 132 to 42, and clearly can be seen from 132 head will be moved to the 187. From 187 to, since no further request in this direction, so we can directly traverse all the requests in decreasing orders. So here you can see, as far as the head moment is concerned, the first of all, the head moment is 100 minus 89, that is 11. Then again 89 to 132, that is 43. Then 130 to 187, that is 55. Then 187 to 42, that is 145. Then from 42 to 23, that is 19. And the total sum is 273. And in the same question, when we have solved using FCFS, the head movement is near about 421. So it's almost half of the FCFS algorithm. Let's discuss few more example. In this question, again, my question is same that I have covered in case of FCFS. Our head movement is, current head position is 53. These are the pending requests of the queue. There are total of 200 cylinders from 0 to 199. So now what we have to calculate, first of all, from the current head position at 53, we have to find out the request that have the minimum seek time. So this end we have the first request is 65. At this end we have the first request is 37. So 53 minus 65 is 12, and 53 minus 37 is 7. So 17. So minimum seek time is 65 point location. So head will be traversed from 53 to 65. Then up from the point of 65, the minimum seek time point will be 67. So from 65 to 67. Then from 67, we have to find out the minimum seek time point. Like in one direction, we have 98, and In other direction, we have 37. So from 67 to 98, then from 67 to 37, जिस भी डायरेक्शन में मिनिमम सीक टाइम होगा, हेड हमारा उसी डायरेक्शन की सर्विस को सर्विस प्रोवाइड करेगा. So we can clearly see from 67 head will be moved towards 37. Okay, now from 37 again the same process will apply here. Head will move to the again minimum peak time point, that is in one direction is 14, in other direction is 98. So clearly we can see head will be moved from 37 to 14. Now no further request in this direction, so head will be reversed in other direction, and in other direction the first service will be at point number 98, then from 98 to 122, then 124, and then last 183. So here the head movement will be 53 minus 65 plus 65 minus 67 plus 65 minus 37 plus 37 minus 14 plus 14 minus 98 plus 98 minus 122 plus 122 minus 124 plus 124 minus 183. Or directly we can say 53 minus 67 plus 67 minus 14 plus 67 minus 40 minus 183. I'm again repeating, I'm taking the difference of 2 points only, not counting the negative values. So in this way we can calculate the total head moment in case of FCFS disk scheduling algorithm. And generally, as I have already mentioned, it half or near about half of the FCFS disk scheduling algorithm. So it is far better than FCFS disk scheduling as far as the head movement is concerned. But there is one drawback also. It suffers from the starvation. Okay. So that's all for SSTF disk scheduling. Thank you, class. In next class, we will discuss some more disk scheduling algorithms